There are two standard forms for expressing a quadratic function. The first is what we call general form, that is a function of the form ax squared plus bx plus c, and the second is what we call vertex form, in which case we can see that there's some grouping of the x variable in that squared expression. If we want to go back and forth between these two forms, that is possible. Going from general form to vertex form, we would complete the square. Going from vertex form to general form, we would just multiply out and simplify. We will focus not so much on going back and forth between these two forms, but working with a function that shows up in either form and getting all of the information that you need out of that function. So first we're going to look at the vertex formula, and the vertex formula applies to a function that is in general form. So say we have a function in general form, we can find the vertex, it's the point hk. The vertex, if we look at this picture down here, the vertex is the point where the parabola turns around. We can find that vertex using this formula here, in which we first find the x-coordinate h. And then after finding h, we plug it in for the input variable in the function and use the output of the function to find k. So in this example here, we have s of t equals negative 16t squared plus 64t plus 4. If we want to find this vertex, which I just marked on the graph here, that's going to be the highest point that this baseball gets to. I can start using h equals minus b over 2a, and looking at the function, I can identify a, b, and c. This is ax squared plus bx plus c, or in this case my input variable is t, but still my a, b, and c are just the coefficients. So a is negative 16, the coefficient of the first term, b is positive 64, and c is positive 4. I don't really use c in the vertex formula, but let's go ahead and write this down. We do need to be careful with signs in this formula, because notice that there is a minus sign in the formula itself. So if I have a negative value for my a or my b, I don't want to let that sign coincide with the negative in the formula. My b is 64, my a is negative 16. I can see that overall I have two negatives in this expression, which is all multiplication and division, so I can already tell that this is going to come out to be a positive value. But I'll go ahead and write it out the long way. 64 over this would be negative 32 on the bottom, and now I can see I have a negative divided by a negative, which is positive 2. I would say a sign error on h is one of the most common mistakes, because sometimes people forget about the negative that is part of the formula. To find k, we're going to go ahead and plug that value that we just calculated for h, turned out to be 2. We're just going to plug that in for the input variable in the function. So let's go ahead and write this out. We get negative 16 times 2 squared plus 64 times 2 plus 4. That's going to be negative 16 times 4 plus 128 plus 4. Negative 16 times 4 is negative 64. I can go ahead and bring in the calculator at this point. That's going to be 16 negative times 4 plus 128 plus 4 gets me 68. And note that the vertex is an ordered pair, so both of these coordinates make up my vertex. The coordinates of this point are 2, 68. So my vertex is at 2, 68. Now we can see from this picture that 2 is a value of time in seconds, and that 68 over here is a value of height in feet. But if we didn't have this picture drawn for us, we would still want to be able to figure out how to interpret these two values. So note that in an ordered pair, when we're working with a function, these numbers are always given to us input first, output last. So just looking at our definition of the input and output variable can tell us what units belong with each of these numbers and how you would use them to answer questions about the function. My input variable is t, which is time in seconds. My output variable is s, or s of t, which is height in feet. So just by assigning these numbers to an input and output variable, I can also figure out what they would have to represent. I need to do this in order to answer a question like this one. After how much time does the baseball reach its maximum height? This is referring to the maximum, and that's what is our clue that the vertex is going to be our answer. But the vertex has two coordinates. I look at this after how much time. Really, it's the input that measures time, so I know that that 2 measured in seconds is going to answer this. So I would say 2 seconds. And what is the maximum height? Well, the output is the height, so I want to use the output value from this vertex to answer this, and my height is measured in feet, so I'm going to say 68 feet.